Kaushal, can you see the recording?
Yes, ma'am.
Okay, good. So today is our 26th lecture. This is our penultimate week of the lectures. And we are looking at pointers in this week. So yesterday we have done basic things about pointers, that is the syntax, semantics, how to access things that are when you have a pointer variable defined. What happens if you do not have a pointer variable initialized? You can get a segmentation fault and so on. And then if you have different type of pointers, for example, we did this in the class, that if you have int star ptr1 and the second pointer is char star ptr2, then the sizes of them are going to be the same. However, although they are going to be pointing to different data types, that is okay. The cell that is given to the pointer has the same amount of storage that we saw using size of. Then we also saw a simple example of swap, which we are going to revisit, and then we are going to do further things using pointers in today's class. Okay, so I just want to have this recap about pointers. That is, when we have an integer variable count, this names a memory cell which is called count, and throughout the program, this same memory cell is going to get accessed when we say count. So whenever we say count as count is equal to count plus 1, or z is equal to count, it is always this memory cell that gets accessed. Depending on how it gets accessed, on which side of the assignment operator, typically we have an assignment operator in the program, or something that where we are accessing the value, or we are going to access the address. Depending on that, we are accessing the accessing either the L value. The L value refers to the left hand side, and this is in context with the assignment operator. Whenever you are having count is equal to, let's say count is equal to 10, then you are accessing the address of this memory location. Whereas whenever you are going to say x is equal to count, you are only accessing its r value or the value, and this r value typically keeps on changing. However, the L value, that is the address of this variable, does not change throughout the course of the program. So whenever we talk about count, its address remains the same throughout the program. On the other hand, whenever we have a pointer variable, let's call it int star count ptr. This means that count ptr is a pointer to an integer. This names a memory cell. Again, it names a memory cell which is called as count ptr. So throughout the program, this same memory cell is going to get accessed when we access count ptr as its L value. This is the same as we did it for the count also. However, when we access its R value, that is the value stored inside this cell, which is this count ptr, this may access different memory cells, because this may hold the address of different variables throughout the program. Because we can say that count ptr is equal to and of x at some point. Later on, we can say count ptr is equal to and of y, and so on. So therefore, whenever we access its R value, we are going to access different memory cells using this count ptr. So this is in some way the difference between these two variable types, that is count and count ptr, just as illustrative two variables. One is an integer, one is a pointer to an integer. So any questions, comments here? Okay, so of course, as you know, that this R value that we are accessing for the pointer is the L value or the address of some other variable. As I said, if you have count ptr is equal to and of x, then it holds the address of x. If you say count ptr is equal to and of y, it is holding the address of y, and so on. Okay, so having said this, we have written, or we have seen a correct program to write the swap function in yesterday's class, and we have seen that for us to write a swap function, we need in some way pass by reference, or we need the addresses of the variables, and therefore we are using pointers to simulate this pass by reference, which is not supported in C. Everything is pass by value. And we took these two integer pointers, which were the parameters to the swap function. Inside the swap function, we are taking an integer t, not an integer pointer t, and then we access the value contained or the value that is pointed to by p1, which is the integer pointer that we have assigned to t, and then we did the routine stuff. An incorrect swap function was also shown to you, which seems to be one of the ways to do it when you have possibly not done the swap function. That is, you define an integer pointer temp, and then you simply swap addresses, which swap it in the function swap. However, they do not swap it for a and b, as we have seen in the last class. This is in the same spirit as you would have written the swap function when you would not have had pointers. So the right hand side is an incorrect version which does not achieve the swap, which is something that we have seen in the last class. So any questions or comments here? Okay. Okay, so let's look at some of the common things that happen when we are dealing with pointers. Let's say we initialize a pointer variable int star ptr. Let's say we have defined a pointer variable ptr1, which is a pointer to an integer, which we have defined as int star ptr1. Before we initialize it, it points to nothing, or it is pointing to some random memory location which may or may not be into your program's allocated memory or the memory that you can access. And therefore, if you write this piece of code where you are saying int count and then int star count ptr, given the names of these variable, it feels like count ptr is going to be a pointer to the variable count. But if you do the following, that is okay. So let's say that count is equal to star count ptr. Let's say we do this, that is, we are accessing whatever is count ptr pointing to. Then we are accessing something for which we count ptr has some garbage or some bits that represent some address, which will be interpreted as some address, and that address, finally that memory cell will be interpreted as an integer. However, that memory cell may or may not be into your program scope. So therefore, this program is most likely going to give you a segmentation fault. Again, I repeat that as long as you're lucky, you will get a segmentation fault. Otherwise, it is going to access some arbitrary memory locations, assign count some value which you are not aware of, and therefore further continue the execution of the program and lead to very surprising behavior which you do not expect. So segmentation fault, however annoying it is something that tells you that there is some error with the program. You are accessing some memory locations which are incorrect. This is something that typically happens the same way that we forget to initialize regular variables like integers, characters, and so on. We forget to initialize pointer variables, and that can lead to segmentation fault. So this is something which is fairly standard, but you should remember to initialize all your variables. Okay, so having said that, we can have a pointer to a variable of some type. Let's call it an integer data type. Let's say we have a integer variable which we have called as var, and its value is 789. And let's say its address is whatever is this address given here below it, xx77, all these things. So this is the address. Then I have defined ptr2 to be pointing to an integer. Therefore, the type of ptr2 is going to be int star, and it will be, so I should have sometime done ptr2 is equal to and of var. Only then this link that is shown here is going to get established. However, ptr2, as we know, is also something which is a memory cell. Therefore, it will have its own address, and this address is given below. this address is this 666x. Again, these are explicit addresses written from some execution. These may not be the addresses that you can reproduce, but let's say this is the address. Then I can define a variable which has the type, which is a pointer to an integer, which has the name ptr1, and I can initialize it to hold the address of ptr2, which itself is a pointer to an integer. Therefore, it holds the address of an integer variable, which is this variable var. So the way you can define a pointer to a pointer is by saying that type, which is, let's say, integer, which is the type of this variable. You can say int star star and the name of the variable. And for example, in this explicit example, you can say int star star ptr1, which will be the way you would have defined this. Of course, you know how to define ptr2, which is by saying int star ptr2. And then, of course, you know how to define var by saying int var. Okay, so this is the piece of code which would have initialized these appropriate addresses. Again, I repeat that these explicit addresses may not be some things that you can achieve, but these are some example addresses which have been obtained by some execution. So the values of var star ptr2, because ptr is simply a pointer to an integer, and star star ptr1 are exactly the same, which is the value which is stored in this cell, which in this case is 789. So you can print out this 789 by three ways. One, which is by saying printf %d var. The other way is by saying printf %d star ptr2. The third way is by saying printf %d star star ptr1. And all of these are correct ways of accessing this, as long as you have set these pointers correctly. So it is perfectly fine to do this only if you have set these addresses correctly by these statements that we have done. ptr2 is equal to and var, ptr1 is equal to and ptr2. Okay, so any questions here? Okay, so I assume that this is clear. I would just like, yes.
The answer
Yeah.
for the last question will be 718 for all three. Right? Yeah, I mean, like, the answer for the last question. The slide.
Will be 789. Yes, yes. It will be 789 for all three. That is what I said. That all of these are different ways of accessing this variable, this value 789 in this case, but whatever is the value in this cell. Yes. Okay. So yeah, one more question that I have is, I have said that it is, I mean, I can actually write down printf %d star star ptr1. Remember, ptr1 is of type pointer to an integer. So let's say I try to write printf %d star ptr1. What do you expect? Is it a what do you expect the program to do at compile time and at runtime?
It will give the address of the PTR2.
Okay, so assuming that these things, okay, yeah.
Small dot, is it %d? What you said?
Yeah, so I'm just saying printf %d star ptr2. If not star ptr2, sorry, star ptr1. If I print out, if I write a statement printf %d star ptr1, what will I get during compile time? What will I get during runtime? So first of all, the question. So one of you said that it will give some address, but before that, I want to ask what will be happening at compile time?
It will give an error, no, ma'am, because the address
So,
is long unsigned.
So it won't give an error, it will give a warning. It will say that the types don't match and you are having a type mismatch. Yet it will take that whatever is there and try to print it out as an integer. And you will get some value, but it is not some value that you want, because again the types are incorrect. So you will get a type mismatch during, or a warning for a type mismatch during the compile time. However, that won't be an error, it won't stop you. but it will print out some integer value, and that won't be meaningful. So it will try to print out whatever is there as an integer, but it won't be meaningful. So what I'm trying to say is that whatever warnings you get, you need to be careful about looking at those warnings and making sure that these warnings are avoided. I have myself been at the fault of leaving that warning of return type of int, but sans that or modulo that, let's go ahead. So all other warnings typically we have avoided. Okay, any other questions or comments here? Okay, so let's get to arrays and pointers, which will lead us to interesting things that we can do. So as we know that when we have an array, let's say we have an integer array of size 4, we have 4 memory cells which are contiguously given to us, and the size of this cell clearly depends on the size of the int on your machine. So assuming that the size of integer is 4, then this is going to be 4 bytes of memory, and then the next address is going to be +4, the next address is going to be +8 from here, and so on. So we know this already. We know that whenever we are referring to ARR is if ARR is the name of the array, then ARR also is the address of the first memory cell. So that is what this first bullet is saying, that the address of the first memory, first element of the array is the same as ARR. This is something that we are aware of. We have printed this earlier and we have seen this. Similarly, and ARR of 1, that is the address of this first, the second element, or which is at index 1, is the same as ARR plus 1. Now, when you do ARR plus 1, this implicitly says that you should move so many bytes ahead. This so many bytes ahead is going to be determined by the type of the array as well as the size of each element of this, size of the data type on that machine. So appropriately, it is going to move those many elements, those many bytes, and therefore the address of ARR1 is the same as ARR plus 1. In the same spirit, address of ARR2 is the same as ARR plus 2. Address of ARR3 is the same as ARR plus 3. So this allows us to use pointers and arrays almost interchangeably, and I'll mention where they differ a little bit, but otherwise we can use them almost similarly. And in general, address of ARR of I is the same as ARR plus I. In the same way, when we want to access the array elements, that is ARR of 0 is giving us the value present in this cell, which is going to be an integer value. This is the same as star of ARR, because ARR is just the address of the first element of the array, which is indexed as 0. Similarly, ARR of 1, which is this cell, can be accessed using star of ARR plus 1. And please note that these brackets are important. So therefore, this is, you're taking ARR plus 1. So you're going to the appropriate memory, appropriate address, and then dereferencing that pointer. So this is another way of accessing the array element indexed at 1. And you can do this similarly for any element indexed in the array. Note that when you are doing this ARR plus whatever value you are putting in here, it is the programmer's responsibility that you are not going array out of bounds. So you should, just like when we say ARR of 3, it is our responsibility that the array does have that index element those many elements, and we are not exceeding the bounds of the array. Similarly, when we are accessing the array using this method, it is our responsibility again to make sure that we are not exceeding the array bounds and making valid accesses always. So this is something that allows us to have 2 different ways of accessing array elements, and talking about the addresses of the arrays in a slightly different way. apart from this and of ARR of 1. So any questions, comments here? Okay. So arrays and pointers really go hand in hand. So as I said earlier, this A of 2, I mean, assuming that these two statements have been executed, if you have an array of size 10 and you say that int star ptr is equal to A, then A of 2 can be equivalently accessed as star of ptr plus 2. Again, please note the brackets. And the above things are, I mean, the way this memory location is accessed is you are going to take the address of this A of 0, which is the same as A, this we know, plus 2 times size of int. Where is this 2 coming from? This 2 is coming from here, whatever index of that element we want, plus into size of int. This much is the offset into the array that we want to go. And this is something that you have already done. I mean, not only for a single dimensional array, for a multi-dimensional array, you have done this, assuming row major form. So this is not new. I'm just emphasizing this once again. The only thing that is slightly different than what is there for this name A versus this PTR is that PTR plus plus or PTR is equal to PTR plus 1 can be done to move this pointer to the next location in the array. However, if you do this, A is equal to A plus 1. So the A is a integer array defined in the following way, as this first statement tells you. Then saying A is equal to A plus 1 in the program is in fact a syntax error. So it won't even compile, it will give you an error because this array name is something which is a constant pointer. So you cannot move that and change that name in the program. So this statement is invalid, whereas you can say PTR is equal to PTR plus 1. So this is a slight difference between the way this A variable versus this PTR variable behaves if you have these two statements making the PTR as well as A having the same address. So any questions, comments here?
Ma'am?
Yes.
A small doubt in the second line, ma'am. Like actually we gave asterisk of A plus 2 and PTR2 are equivalent ways of accessing the same element. Asterisk of A plus 2 will access the element in A of 2 only, no ma'am. How will it access
Yes.
PTR of 2? Okay, will
So,
PTR
okay.
also be...
No, so the assumption is that int star PTR is equal to A has been done earlier.
So basically PTR also will become the same array, no ma'am. It will be...
Yeah, as long as, but remember that PTR can move around. I mean, PTR can go to something else, right? So at this point, PTR is pointing to A, that is okay, right? But if you do PTR plus plus, then PTR of 2 need not be the same as A of 2, right? If you do PTR plus plus, PTR has moved one location ahead, but A continues to remain at the same point. So all these statements are valid, assuming that these two statements are there and PTR has not moved anywhere.
Okay, ma'am.
Yeah. Yeah. Any other question or comment? Okay. So now that we understand arrays and pointers, yes.
Ma'am, but in our recursion problems, we used to do A plus plus also, right? Array plus plus, shifting the address of the array.
Yes.
Ma'am, so here, why is it not possible? A equals to A plus 1?
No. Where did we do? So where did you do A plus plus?
Ma'am, during our recursion problems, like while going through the elements, we are shifting the address by 1.
So what did you do there?
Ma'am, like while passing again to the function, we used to write A plus plus instead of A
So
equals.
we did not write A plus plus, we write A plus 1. So I am not saying that A plus 1 is
Okay, yeah.
incorrect, but A is equal to A plus 1 is incorrect.
Yes, ma'am. Got it. Yes, ma'am.
Right? Okay. Yeah. So I think there are some questions in the chat. I'll read them before we go to this thing. Okay. So Okay, so I think one of the okay, so I think people are answering your question, but yeah, so Shwetika, I don't understand the question. Won't the size of the array matter when incrementing the array? Okay, which statement, Shwetika? So we are not incrementing the array, we are incrementing the pointers. So which statement? Can you unmute yourself? Okay, so I think again there is some connection issue. Please ask this question later during the end of the meeting or something. Okay, so yeah, so let's look at the following program and try to see what is the output of the program. Since there are 10 outputs that are, in fact, 30 outputs that are to be written, so let's not write down 30 outputs, but you have to read through the program, understand what the program is doing. It's a simple program, and maybe you should write down what is the output of the for loop when I is equal to, let's say, 0, 1, 2, 3. So let's say at I is equal to 3, what is the output of this loop? There are 3 printf statements, and so therefore if you write this program, there will be 10 lines printed out. Each line will have 3 values which are tab separated. So just write down what is the value at I is equal to 3 that is getting printed out by the 3 printf statements in this loop, right? So just write that and write down that in the chat, and we will take the answers. It's a simple program. There's nothing tricky about it. Okay, so there are about 4 or 5 people who have answered, which is good, but others have not answered. So okay, so the first printf statement is not difficult because it's just the array access. So it is at I is equal to 3, you just have to go to 0, 1, 2, 3, and therefore 5 will get printed. So that is clear. There is nothing difficult about it. So that will get printed. Then the next is something that we have discussed in the previous slide. So because we have said that PTR is pointing to the is a pointer to the first element of the array. Therefore, star of PT star into the bracket PTR plus I is the same as A of I. Therefore, that will also print out exactly this, which is 5. So the first two printf should be clear to everybody. The next printf is something that may be a little confusing if you have not paid attention at it carefully. So PTR has not changed throughout these loops, right? So therefore PTR has not moved ahead. PTR continues to be at the first is holding the address of the first element in the array. Therefore it continues to be at 12. And we are doing star PTR plus I. Here is where you will require to look up your table. That is, you need to know which amongst these bind have higher precedence, and star has higher precedence. Therefore, it is going to access the memory location pointed to by PTR, which is 12, and do plus I, which in this case happens to be 3. Therefore, it is going to do 12 plus 3. Therefore, it is going to print out 15. So if you just look at one row of this printf, one row of this for loop, this is going to be 5, 5, 15, which is at I is equal to 3. In the whole program will have the following output. That is, in the first two columns, it is just going to print out the array elements as it is: 12, 3, 4, 5, 8, 16, and so on, in the same order in the first two columns. In the last column, it will print out 12, 13, 14, 15, 16, 17, and so on, because it is just taking this element 12 and adding 1 to it in every iteration. not a 1, it is adding I to it in every iteration. So in the first iteration, it adds 0. In the next iteration, it adds 1, and so on. So this is how this program behaves. There were some answers which were different from this, which is expected, but I hope everybody who said something else now understands why it will be that 5, 5, 15 will be printed out when I is equal to 3. So any questions or queries here? Okay. Yes.
Just one small confirmation from the previous slide. Like actually, your PTR can be incremented, but A cannot be incremented, right? Like,
so what I'm saying is this, so you could have written PTR is equal to PTR plus 1, but A is equal to A plus 1 is not allowed. But you can write some other pointer, or PTR is, I mean, this statement is invalid, but you can write PTR is equal to A plus 2, PTR is equal to A plus 1, and so on. But A itself cannot be incremented. That's what I'm saying. The incremented value of A cannot be assigned to anybody else is not, it can be assigned. That is what all of us have agreed. We have done it also earlier.
okay.
Right? So if you have another pointer int star B or int star PTR2, then you can say PTR2 is equal to A plus 1 or PTR2 is equal to A plus 5. That is allowed. Even if the array is not having 5 elements, it is still allowed, but it will be invalid access when you access it. But you cannot change this A itself to point to something else. That's what I am saying.
So A is always going to remain at the start of the array. Like it will always remain.
Yes.
Okay.
Yeah. Okay. Any other questions on this or the others, or this next slide? Okay. So having done this, let's do another example of arrays and functions and character arrays and functions. So this string copy is something that we require very often. In fact, just like integers, we want to assign x to y, we want to assign string 1 to string 2 or string 2 to string 1. However, we have seen that string 1 to string 2 assigning cannot be done the way we do it for basic data types like characters, floats, and integers. We have to do the copy character by character, and we have written it in main. We can write easily a function for that. And remember that while it is pass by value, both source and destination, we know that these are addresses. Therefore, the modifications done to the destination are going to be reflected in the caller, which is the main. So what this program does is it has a character array S1, which has size 20, and it has some string, and the string itself is called, this is a string. When you say this, there is an implicit /0 that is there, which we all remember. And S2 has been given memory, is also a character array of size 20, but it has not been initialized. But there is memory given to S2, which is because we have defined it as a character array of size 20. After this, we are calling this function my strcpy s1 to s2, and it is the responsibility of the person who defines this prototype to say that whether it is going to copy it from s1 to s2 or s2 to s1. In this case, clearly the prototype says that the first parameter is the source, the second parameter is the destination, and again, it is the responsibility of the caller to have the destination to have enough memory location, so that memory cells, so that we can copy source into destination. So the program is simple. It's using built-in functions. So in fact, there is a strcpy which we have not used, but we are using the string length strlen from the string library, and we are finding the length of the string, and then from I is equal to 0 to I less than the length, we are going to copy into destination of I whatever is in source of I. So this is something which is fairly straightforward. At the end of it, it is your responsibility, or the string copy responsibility, to make sure that the destination string is also terminated by a /0. Therefore, you are going to put in at destination I/0. Note that this for loop has terminated with the value of I is exactly equal to length, because that is why it has terminated, because I has become equal to len, and at len you are going to put out a /0. So this is something that we know how to do. We are going to see a pointer version of it, which will use it as pointers and not as array accesses. So before I go to that version, is there any question or comment here? Okay, so okay, so this is the version which is the pointer version. Nothing has changed in main. The main program is as it is. The pointer version of the my strcpy is saying that it, instead of taking a character array, it is taking a pointer to a character, which is this source, and the another pointer to a character, which is the destination. Again, it is the caller's responsibility to make sure that destination has enough memory cells to copy source into it. That is something which is it is the caller's responsibility. So while star source, this is equivalent to saying that star source is not equal to 0, or source of I, if we had used the index into the array, source of I is not equal to 0 or /0, you continue doing something. Now instead of saying destination of I, we are saying star destination is equal to star source. So note that these are okay, so I'll just try to annotate it once again. Yeah, so this is the source and it has several of these cells, and there is this destination which may have different number of cells. In this case, it happens to be both of them are the same. So initially source and destination are pointing here, and when you say star destination is equal to star source, so this cell is going to, this is destination, this cell is going to get whatever is the content of this. In this case, it contains a capital T, so it is going to take that capital T and copy it here. Then it moves destination. So destination moves from here to this place, which is the next cell into the destination. Similarly, source also moves here. So source moves from here to here, which is the next cell, and so on, as long as we don't see a /0, at which point star source is going to become equal to 0 or equal to /0, and therefore the program is going to terminate. At that point, destination, whatever is the destination, you are going to put a /0 into the destination to make sure that destination is also a string which is terminated by a /0. So this is the pointer version of the program, and it does not use the square braces to access the array, but it is equivalent to the earlier version. It does exactly the same. Any questions here? Okay, so
Ma'am,
yes.
ma'am, here why cannot instead only we write that the destination source address is equal to the source address, so that the computer will automatically know, right? The whole.
I did not get. So can you repeat your, why can't we write?
Ma'am, like if we
Destination.
like we have the source array and we have the destination. I mean, in that sense. So suppose we give the address of source to destination. Now destination is pointing to the first letter of the string, right?
Okay, but is that what you want? So this is okay. So the question that good, it's a very good question. So what Rishabh is asking is that why do you have to copy it? Why can't you change the pointer? So is that what is the thing that you want to do first of all?
No, ma'am, I'm not like changing the pointer, right? I'm just telling it that you also point to this. Okay, I'm not making another variable, right? Okay,
No,
yes,
you
ma'am.
are
Got.
not copying it into the S2, right? You're not copying it into S2 at all.
Yes, ma'am. I'm just pointing to S2.
Yes, yes.
Okay.
That is not what is expected. Just like swap, right? If you are given A and B, and if you do printf B and A, it does swap it externally. I mean, the printfs are printed in a different way, but that is not what internally X and Y continue to be, or A and B continue to have the values 10 and 20.
Yes, ma'am. Yes, ma'am. Got it.
Yeah. Yeah. So we don't want the pointers to be swapped. We want it to be copied.
Ma'am, like
Pointers to point to each other. We don't want that. Yeah. Yes. One more question was there, Ashwin.
ma'am, if we are about to do what Rishabh said, then just one iteration will be enough, right? Like we just have to do it for the starting value, and then begin it.
Okay, so let me come to that. I mean, first of all, that is not what we want to do. We'll
Yes,
come
ma'am.
to that in a minute, but let's just. So I'm saying that we should not be changing the pointers, and let's just hold on to this. That is not the correct thing to be done at this stage. We'll come to that variant or something that does something similar in a few minutes in the slides later. So let's just hold on to that question.
Yes. Yeah.
Sure. Okay, so I think this is a good time to take a short break, and then we'll resume after 2-3 minutes. I'll just pause the recording. Can I pause the recording, Akhil?
Yeah, like just 1 second, ma'am. I had a doubt here.
Sure. Yeah, okay, go ahead.
S2 size was lesser than S1 size, ma'am. Here, like say S2 is 5 here, S2 size is 5, S2 of 5.
Okay.
So like, could you just go through what would happen in my STR in the inside that while loop, ma'am?
Okay, so let us say that S2 size is 5, right? You are saying that S2 was given a size of 5 here, right?
Yes, ma'am.
Okay, so the my strcpy has no clue of what is the size of, I mean, what is the size of the array pointed to by the destination, right? It is simply doing this copy as long as it doesn't see a /0 in the source. So let's count this. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then this is 5, right? Yeah, so 15 plus, so this is a string of length 15, right? The whole thing using including the spaces. So 16, I think, sorry. So it is a string of length 16 terminated by a /0, right? So till 5 there won't be any problems, because till 5, that is still this space, there won't be any problems. After this, you are accessing memory locations which are not some things that are in your program's control. So you may get a seg fault, you may not get a seg fault, and it depends on the execution of the program.
Yeah, like because when you do dest plus plus, it will access a memory location. It will take an address next to the last element in S2, but that address isn't actually a part of S2.
Okay, yeah, so let me just try to annotate and show it here. So okay, so let's say that we have only 5 cells. 1, 2, 3, 4, 1, 2, 3, 4, 5, right? So after you have completed copying T, H, I, S and the space, you are going to access this cell, right?
Yes.
I mean, this memory location. So this memory location, so I'm just drawing this vertical bar because I want to show that S2 had only space of 5 cells. So after this, you are going to access this. This cell could be a valid access into your program, and therefore you may not get a seg fault if you're unlucky. You can get a seg fault because you're accessing this cell which is outside your program's memory locations, and therefore you may get a seg fault, or it may if it is allowed, or if it is not, I mean, if it is okay, it will copy it, and then later on something else can get written, because this array was only of size 5. So your program may misbehave, or it may actually give a seg fault. It depends on the execution.
Okay, but the while loop actually the condition is still satisfied, so it keeps moving on.
Yes, while loop goes on and it will keep continuing as long as these 16 cells are not copied into the cells here. So the program, if it seg fault, then of course it terminates, but if it doesn't, then it keeps continuing to copy.
Okay, thank you.
Yeah, okay. Yeah, so it, as I said, it depends on how lucky you are. If you're lucky, it will seg fault, otherwise it will go on, it will copy. and then it will misbehave at a later point.
Yes, ma'am.
Okay. Okay, so at this stage, I'm going to pause the recording. Okay, so let's now move to another kind of small task that we want to do. So we wish to store three names, right, in some appropriate data type, and in fact it need not be three names, it could be multiple names, but also you should observe that these names are chosen so that they are of different sizes. That is, and as you, I mean, all of our names have different number of characters, so they are of different sizes. So what kind of data type will you use, or what kind of a variable will you define so that we can store these three names? Let's start with these three, and as we go along, we can have all your names stored in some appropriate data type. So let me understand, how would you store these? So what are your suggestions? How will you define some thing to store these three student names? Okay, 2D arrays is one suggestion. Yeah. So this is my suggestion also. That is, it is a 2D character array of 3 rows and 11 columns. Where did I choose this 11, and why did I choose this 11? Any thoughts? So why would I have chosen 3 cross 11 only and not something else?
And
Okay,
because
so the
last
longest
someone
name
is of
is, yeah,
10
good.
and then slash 0.
Yes, so the longest name here is Narasimhan, which is 10, and then I would like to have them as strings, because only then I will be able to do something with strings that is possible, because we have seen earlier when we had character grids where we did not store them as strings, then we could not use anything related to character strings. So this is something that is a possibility. That is, character, it is a two-dimensional array or a matrix of 3 cross 11, right? So this is okay, and this is one way of doing this. Is there something bad or something, I mean, something not so nice about this kind of a representation? So yeah, Naresh, I will come to your answer, but is there something bad about bad, or is, yeah, uh, yeah, it is how to change it if longer names come. So assuming that these are three names only, we still have wastage of space, because we have small names like Sai where we require just 4 characters and we are still having 11 characters given for it. Similarly, Lakshmi is also smaller than Narsimhan, and still we are giving 11 characters to it, which is kind of wasteful, right? So how about if we say that it is an array which is of size 3? This names is an array of size 3. However, each element here is a pointer to a character, right? So that is all we are saying. It is a pointer to a character, and uh, what does this tell us? Do we have space to store this? Do we have, do we have actually the space to store this? The first question that I want to ask is this a valid, even a valid thing to do? This is the first time we are doing this. Is this a valid variable which we have defined, which is names, which is a character, which is a array of size 3, and each element is a pointer to a character? So is this okay? Okay, so people seem to be saying that it is fine. So first thing that I want to ask you is that if we have this type of a variable defined, how much space have we allocated in memory? How much space have we given, and what, how much, I mean,
8
do
into
we
3.
have enough space to store everything? that we want to. Okay, so people are writing 24. Where is this magical number 24 coming in? Okay, 3 bytes we have stored. We have 3 bytes. I hope 24, when it was written, it means 24 bytes, or is it 24 bits? Okay, so one small exercise for you to do is define this variable char star names of names 3, which all of you agree that it is a valid thing to do, and then do printf size of names and see how many bytes does it give. I mean, one of the things that people are answering is 24. It is 24 bytes, and the reason that it is coming in is that there are 3 things that we have. I mean, this is an array of size 3. Each is just a pointer to a character, and this pointer itself requires space. So we have assigned the space for the pointer, but we have not assigned the space for the names that we want to store. The names, that is Sai, Lakshmi and Narsimhan, they do not have space assigned to them. So in fact, whatever is the size of a pointer in your machine, let's say it's 8 bytes, assuming that people have written down the answer as it is 8 into 3, which is 24. So if you do size of on this, you should be getting either 24 or 3 into 4 if the size of the pointer is 4. Accordingly, you will get the answer. So please do this in your machines and try this out. Okay, so names is an array of pointers to characters, and let's now see. We can use the following a program to initialize this names, which is an array of pointers to characters, to contain the appropriate names. So let's study this single line which is doing all the work. So this is the only line which is slightly new. So this is saying that names is an array which is an array of pointers to characters. There are 3 such pointers, and not only that I have defined this and allocated memory, I am also initializing them. Just like when you do when you do char names, let's say there was no star, or let's just use another variable, char str with empty square braces is equal to this is a string. This is allowed because then appropriate storage is given. Similarly, each of these is going to be initialized appropriately with SAI, Narsimhan and Lakshmi appropriately, and a /0 is appropriately placed at the end of each of these strings. This is what this initialization means. So this will not only define the array of size 3, which each of which contains a pointer to a character, it will also initialize those pointers to these constant strings which are Sai, Narsimhan and Lakshmi with a /0. So after you have done this, you can in fact print out the names by saying that for I is equal to 0 to I less than 3, I plus plus, and printf these names, and it will appropriately print out these names. So any questions or comments on this program? Okay. Also, I would like to, okay, so I think there is a small error. It should not be printf %c, it should be printf %s star names of I, and then it will appropriately print out these names. Sorry about this. So this should have been %s, not %c. Okay. Yeah.
Ma'am,
So,
just a
yes.
minute, ma'am.
Yeah.
If we have a character variable which has been initialized, not an array, ma'am, not an array, which has been initialized. So if we want to put that value of character variable into this pointers, ma'am, into the array of pointers, can we do it like names of I is equivalent to ampersand of that character string or something? Like for
Okay.
example,
So
if this Narsimhan is initialized to a character, say C, ma'am, C is a string. Like example, C string and so.
Okay, just let me understand your this thing. So okay, so you have some yeah. Okay, please go ahead with your program. Okay, so I think you have
Yes, ma'am.
something in mind. So int sorry, char ch is equal to, let's say, a, single quotes a, right? That is what you want. Okay.
Okay, ma'am. Well, okay, ma'am. So if we want to store the value a into this array of pointers using the variable ch, so can I write names of say for example 0? Names of 0 is equal to ampersand ch. Can I do that, ma'am?
Ampersand ch. Yes, it should be possible.
Okay.
Yeah. Okay. So okay, so coming to the question that one of you is asking on chat, that can the names be input using scanf? So that is precisely what we want to do. That is, read 3 names from standard input instead of initializing them the way I have done this, and then read them from the standard input. So let's read this program and try to understand whether it does what we want to do. So I think this is what is the question that Pramath has asked, right? You want to read it from the standard input. Is that right? Okay. Okay, sure. So let's say we have defined this the same way, that is char star names 3, but of course we have not initialized them because we want to read them from the standard input. And then we say for I is equal to 0 to I less than 3, enter the name, enter this name 1, name 2, name 3. Of course, instead of saying name 0, name 1, name 2, we are saying name 1, name 2, name 3. And then scanf percentage names of I. So is this a correct thing to do? Yeah, so Pramath, you had asked this question that can we read it from the standard input? Can we do this using this program? Okay, any thoughts? Is this a correct program? Is this an incorrect program? Okay, seems to be correct. Okay. Okay. So, okay. So, since many of you have, there are, so no get char is not required. Don't worry about it. There is no error of that get char type. Don't worry about that. Okay. So let's now first compile this program on our REPL, see what happens, and also see this on the so unfortunately, the visualization doesn't allow us to do scanf, so it won't allow us to visualize. But let's first see what happens when this names of 3 is allocated, right? So I hope you can see the see my screen completely. So I'm going to so yeah, Kaushal, can you confirm that you can see my screen completely?
Yes, ma'am.
Okay. So yeah, so int main, let me just write the following, char star names of 3, and yeah, I won't even run the initialization. Let us, I mean, yeah, let us just see this execution and see what happens here. Yeah, so so only this, okay, so this names is an array of size 3. These are 0, 1, 2 access 0, 1, 2 indices into the array, and these are pointers which have not been initialized. So this is the memory that has been allocated by this statement. So when we did this code, which is for I is equal to 0 to I less than 3, I plus plus. So let me just write it here and then copy it to repl.it. So, this this visualizer does not allow you to do scanf. So what I will have to do is I'll just do strcpy names of I, and let's say I'm just copying the same string into all of them, which is not interesting, but I'll just do that for illustration. /n, but here, okay, and that's all is the program, right? And then of course I want to printf also, but even before you do as printf, let me just try to run this program. So is this clear? I'm not doing scanf because this visualizer does not allow you to use scanf. Okay, so I is equal to 0. It is trying to copy this, which is trying to copy into names of I this string AAA. However, this is using this uninitialized value, and therefore it doesn't know where to copy. So in fact, if you run it in repl.it, it is most likely going to give you a seg fault because you have not allocated space for this for storing this any name that you are interested in. So if you do this program or if you run this program directly, you are most likely going to get a segmentation fault in repl.it, because not because there is any error, it is because you have not allocated space for names of I. Yeah, that is only a pointer and it is not pointing to anything. So you have, because you have not given space, you cannot use scanf and ask scanf to enter something, any long name into that names of I, because it's just a pointer which has not been initialized. So people who said that it is a correct program, it is incorrect. It will compile correctly, but it won't run correctly. So, yeah.
Wait, what do you mean by we didn't allocate any space to that thing, man?
Okay, so so what it has done is these are pointers. These are pointers which are pointing to nothing. So these are pointers, each of a fixed size, which is of size 8 or size 4, whatever depends on the size of the pointer. But the name itself can be any long name for which we have not allocated memory, right? So unlike this, in the previous program, we have already not only allocated space for this, we have also allocated, we have also had this cells which are, memory which has been allocated for SAI, Narsimhan and the /0 and so on. So maybe that itself will work and I can show you what it means to allocate memory there. Just give me a minute. I'll not run this.
So is it like when you create these pointers without initializing them to something, then they are null pointers?
So Chinmay, right? I am unable to hear you. Just give me a moment. Let me finish this writing and then we can. Okay. Okay. So let's see this visualization, which is. So there is some error in my initialization. Okay, there is an extra /0. It's not extra. Okay. Okay. So you were saying something, Chinmay.
So if you don't initialize the pointer at first, does it behave like a null pointer or something? Or?
Yeah, so it is pointing to any, I mean, it is containing some garbage. In this case, I think it is not, I mean, the execution doesn't even proceed if you do not have it. In our repel.it, it is most likely going to give you a segmentation fault because it is going to access some garbage locations.
No, but
So, yeah, so let's just run. Yeah, just give me a moment. So if we had initialized this, then I hope everybody can see that there is an array of size 3, which array which is called names, which is of size 3, which has been allocated space. In addition, there is some space which has been allocated to uh, these names, which are Sai, Narsimhan, and Lakshmi, and they themselves require this 4 size here, 10, 11 size here, and whatever size here. And this space is not allocated by the previous program, which was trying to read this scanf, which is this program on the slide that I was showing. This one, right? This program does not allocate this space which is required, which we must allocate in some way. Yeah. Yeah, so is this execution clear, and what am I saying by space is not allocated? Is it clear?
Ma'am? So does that mean a pointer doesn't point to any location in the last program, ma'am? Is that
It not only it does not point to any location, we have not even taken any attempt to we have not made any attempt to even take memory for this name Sai or Narsimhan, right? Which we have not done. So therefore it is not pointing to anything, or it may be pointing to some garbage location, but we have never even made an attempt to take memory or allocate memory to store this name Sai. That is what I want to say, that we haven't allocated memory for these names. Is that clear?
okay? Yes,
ma'am. So suppose I create some normal variable like some int a or something like that, then
Okay.
does that store some random integer or?
Yes. Uninitialized value, if you are saying simply an integer variable, right? Int
Yes,
a.
ma'am. But like the
Yes.
pointer, it doesn't point to a random location, ma'am.
It will point to a random. So in this visualization, right, somehow the uninitialized values are shown as a question mark, but in general, it will contain some address and it is pointing to some address. So it will be holding some address. Unless it is initialized, it is going to hold some arbitrary address, random address. Yes. The
Okay, ma'am.
visualization is slightly a different thing because it is telling us, okay, till now you have not initialized these variables.
Okay, ma'am.
Yeah. So you can do int a in the REPL and say that %printf %da. It is not like, it is unlikely that it will print out 0. It will print out some random value. Is that clear?
Yes, ma'am.
Yeah. Was that your question, or?
Yes, ma'am. My question was that if it pointed to some random location, then like doesn't why can't it just store? Why can't it just sort of
Use that memory cells
yeah
and store size,
use
right?
that as
Yeah, but
successive ones?
that memory location may not be in your programs. The set of memory cells that your program can access. So you
Oh,
may
okay.
be
So it
doing
may go to
invalid
illegal.
accesses.
It may go
Yeah,
into
it will
some.
be illegal access, and therefore
Okay, ma'am.
most likely you will get a seg fault.
Okay, ma'am.
Yeah. Okay, so I think we are 5 minutes overshoot. We have overshot the time. I'm going to stop the recording. I'm going to stop the class, and I'll be here for a few minutes if you have any questions.